All right, so I'm recording this video with 5 minutes left in the period, so if you hear a bell ring, we'll just work through it. It'll almost be like we're in school. So, the last section for chapter 4, well, not the last section for chapter 4, but one of the last sections that we're going to cover as far as triangles is concerned is equilateral triangles. All right, so if you don't remember, when we talked about equilateral triangles from before, we know that all the sides are the same. And we should also remember that if the sides are the same, then those opposite angles are also the same as well. So all three angles are the same and all three sides are the same. So a triangle is equilateral if and only if it is equiangular. So we should know that angle A and angle B and angle C, if they're all the same, then the sides are the same. Then AB is the same as the value of BC. And we know that that's the same as the value of AC. All right, so we will be able to set those equal to each other. So then over here, if we have AB is equal to BC, which is equal to AC, is pretty much the same thing about the sides. Then we know that the measure, then we know that the measure of angle A is the same as the measure of angle B, and that's the same as the measure of angle C. And the one thing that you're going to be able to have to remember about this is that if all three of these are the same and they should all equal to 180, the only way that that can happen is if all of the angles are 60 degrees. All right, that's going to be really helpful when it comes to some of these problems. So let's go ahead and just jump straight into the first example. It says find the missing sides and angles of each triangle. Well, first of all, I just went ahead and already said that if all of the angles in an equilateral triangle are 60 degrees. So if this is 60 and that's 60, then this third side can be found by either subtracting 180 minus both of those, and you'll end up with 60 degrees. So that's already telling you that this is an equiangular triangle, which means it's equilateral. And if it's equilateral, then if this is 9 and then this is 9, and that's 9 as well. All right. So this right here is telling you that if all these tick marks are indicating that these all have the same measure, so that means that this is 24 and this is 24. And if we have an equilateral triangle, then that means that all the angles are the same, which means that they're all 60 degrees. All right, it's as straightforward as it's going to get. All right, sorry about that, I got interrupted. So let's continue this. If PQR is an equilateral triangle, solve for X and Y. So this is a bit more complicated, but really if you kind of understand your properties, it's not so bad. So the fact that it's an equilateral triangle, well, we know that all of the angles are equal to 60 degrees. So I know that this is 60, that's 60, and that's 60 as well. So right there, it'll be really easy to figure out what is the value of X, because if this angle is 60 degrees, but it's also 7x minus 3, let's just set 7x minus 3 equal to 60. So now let's just go ahead and do our basic algebra. So we have 7x is equal to 63. Divided by 7, we get x is equal to 9. And then, if we know that this is an equilateral triangle, well, I know that this side is the same as that side, which is the same as that side. So pick any two sides that you want. All right, I'll pick this one and this one, right? You could easily pick these two or these two, set them equal to each other and solve for y. You should get the same thing. So I'm going to get 11y minus 23 and set that equal to 9y plus 1. So in order to get y by itself, I'm going to go ahead and do my algebra. I'm going to subtract 9y from both sides. At the same time, I'm going to add 23 to both sides. Those cancel, those cancel. I'll end up with 2y is equal to 24. And then I get y is equal to 12 after dividing both sides by 2. So it looked complicated. You had a lot of different variables in there, a lot of different expressions, but it turned out to not be so bad. All right. This one also isn't so bad if you just kind of think about your properties of a triangle. So I'm going to zoom in because some of those numbers are small. But it says, given that triangle ABC is an isosceles triangle. All right, so now we're bringing back some old terminology. So we know the triangle A, B, and C. So this right here is an isosceles triangle. So I know that these two sides are the same. All right. And triangle DBE, so DBE is an equilateral triangle, so that means I know that all of these sides are the same. Find each missing angle. Well, I'm going to start off simple. I think it's been established now that if we have an equilateral triangle, then all of these angles are the same, right? So angles 4, 5, and 6, 60 degrees, right? That one was pretty simple. All right. What would I do next? So here's an interesting one. So with this one, if I want to figure out angle 3, well, I can remember that the two angles that form a line is equal to 180 degrees. So I know that angle 3 is 180 minus 60, which gives me 120. So angle 3 is 120 degrees, and it's pretty much the same thing over here. This is 60 and they form a line. Angle 8 is also going to be 120 degrees. All right. So let's kind of see what else we've got here. Well, here's the thing. If I know that ABC is an isosceles triangle, well, I know that these two base angles are going to be the same. So we're going to have to do a little bit of algebra here. So I know that angle 1 is equal to angle 9. So I can set 4x minus 3 and 9x minus 47 equal to each other. So 4x plus 3, sorry. 4x plus 3 is equal to 9x minus 47. So I'll just do my algebra here, minus 4x from both sides, add 47 to both sides. So now those cancel, those cancel. So now I have 50 is equal to 5x. Divide both sides by 5, and I get x is equal to 10. Now that's not necessarily the measure of the angle, that's just my x value. So I'm going to substitute this. I'll substitute into this one. I have 4, now that I know that x is 10 plus 3, well, that's going to be 43. So I know if angle 1 is 43, then angle 9 is also 43 degrees. Okay? So now I'm going to look at and figure out what is angle 2 and angle 7. Well, here's the thing. I'm going to go ahead and redraw this triangle separately, triangle ADB. So I'll draw it out like this. So I already know that this angle is 120 degrees because I figured that out earlier. And I know that angle 1 is 43 degrees. So I know that the measure of two angles, that third angle should be simple to find. All I have to do is subtract, get 180 minus those two angles. And then I should get, I'm trying to do it in my head, 180 minus 163 is the same thing as 17 degrees. So there are my two missing angles. So hopefully that was straightforward enough. If not, make sure you ask any of us any questions that you have. But that should be enough to get you through the problem set. So hopefully you have a decent time with it, and take care.